Okay, welcome back. So let's talk about this topic called AWS Lambda. So let me give you some background here before we get into Lambda and serverless and others, right? So years back, before AWS came in, or as a matter of fact, any of this whole cloud computing came in. So when you need a server, let's say a web server or database server, so you will have to put a request for the physical machine, physical server that has to arrive, and then your provisioning team, your network team, and the middleware team takes anywhere from a couple of days to a couple of weeks to provision them, to get that set up in appropriate subnet and all. So that's a physical machine days when you don't have any virtual machine concept. So, and then this concept of virtual machine came in. So where you have a physical in the bottom, but you have your host operating system, but on top of it you have your hypervisor, and then you can virtualize into multiple virtual machines. One physical box can be virtualized into multiple virtual machines. And then again, you can install your own favorite operating system on each virtual machine. That's what we've been playing with this EC2. So that came up, and then industry has realized that, well, cloud computing and providers like AWS, Amazon, and so Amazon, Microsoft, and Google, like cloud providers, they popularized this whole concept of virtual machines. And then, industry has felt that, okay, it's the same kind of, as long as the same kind of application, let's say Java-based application. So why do I need, when I have 100 applications, why do I need 100 VMs, 100 virtual machines? Everybody is wasting a lot of resources in the form of operating system. So I don't need it. These are all pretty much same Java stack. So why do I need the virtual machines? Rather, I can have on one virtual machine, you can create multiple very lightweight containers. So that's where the the concept of container came into picture, like Docker. And then their container orchestrations came into picture, like Kubernetes. And on the other side, you have people like Pivotal Cloud Foundry and all. So this whole containerization came into picture, and it popularized, and it's still very popular. So we went from physical machines to virtual machines to containers, and then we got into this this state where, why do I need to worry about even at the container level, and then container orchestration, and then why auto scaling and all of that. Yes, you can do auto scaling at the virtual machine level, at the EC2 level. We have seen that using auto scaling group concept here. You can do the same thing with containers also. But why do I need all of that? I have a piece of code. I need to be able to deploy this piece of code and forget about how it gets deployed and forget about where it gets deployed, and I don't care how. Somehow magic happens. I have a piece of code. I will write it according to the contract, according to the standards that the deployment environment has dictated. I'll develop my code, I upload my code, and then I don't worry about it. I don't worry about scaling. I don't worry about underlying infrastructure. I don't worry about, forget about the virtual machines. I don't worry about the operating system level. I don't have to worry about containers. I don't have to worry about anything. I just have a piece of code. And it makes event-driven architecture more possible. Event-driven architecture means that when an event happens, you trigger something when an event happens. That's essentially an event-driven architecture. So it's all event-based. So this concept is called, it's a function as a service, like how we have this, infrastructure as a service, platform as a service, and software as a service. It comes under pretty much, somewhere in between. Not so much, yeah, it comes under not so much on the platform side, platform as a service, or a little above. It's called function as a service. So you write a function using one of the popular programming languages. You deploy your function there, and then you can associate your triggers. So when should this function be called? Okay, as soon as I upload an object into S3 bucket, call this function. You define that function. You give some name, and then you specify how much memory needs to be allocated for this function. And behind the scenes, don't worry about scaling. Don't worry about anything. Amazon will take care of everything. Your function will be able to scale anywhere from 1 request per day to 1 million requests per hour or per minute. So it will automatically scale without you having to worry about it. And you pay for what you use. Let's say you have EC2 instance and you have your Apache for your simple static website or even dynamic website. Your Tomcat, Java-based web app, you installed it there and you deployed it. Let's say you're getting very less traffic, only 10 requests per day in the beginning. You are wasting your computing resources for the remaining time. You have your virtual machine up and running all the time. Well, all that is gone. You just write your piece of code and deploy it. And then you just define your triggers. When should this code be called? Define an event. That's where the event-driven architecture come into picture. So that's a function as a service. And in the case of Amazon, it's called AWS Lambdas. It's a very powerful architecture, and it made event-driven architecture much more feasible, reality, and easier to implement. And also, with the AWS Lambdas, there is another concept called API Gateway, which we'll look into it tomorrow. The combination of these two, they made serverless a possibility, serverless even web applications, serverless, your mobile apps, mobile-based applications, mobile-based backends, I mean. Okay, so it's all serverless architecture. This is the new trend, guys. And there are actually some conferences, they're called serverless conferences, all over the US. So this is the new trend. Pretty much, don't worry about servers. Don't worry about virtual machines. Don't worry about containers. You just write your code, deploy it, and forget about scaling. Forget about availability. It will automatically, Amazon will take care of, placing it in appropriate availability zone so that even if one availability zone is down, your function will work. So it takes care of scalability, it takes care of availability, and you pay for the resources, the computing resource only when it's in use. You can reduce your bill quite a bit. So that's AWS Lambdas. Okay, and I think Google Cloud, Google also has this concept called Cloud Function. So Google actually went in this direction. When a cloud was starting up, Amazon went into this direction of infrastructure as a service. How do I make this, creating of virtual machine easy? So Amazon went into this direction, but Google never believed in it. Google went in a different direction, saying that, hey, these people don't have to worry about, fundamentally your computing EC2 resources and all that stuff. So you just write your code, deploy it, and forget about how it gets deployed. It works. It works for all of your new architecture. It works for your new code. If you're starting a brand new initiative, you definitely can go in this direction. But if you want to migrate your existing stuff, obviously this doesn't work. So that's why you need your EC2 instances, your application load balancer, everything. Here you don't have to worry about anything. It will automatically infinitely scale. So AWS Lambda lets you run code without provisioning or managing servers. There's no concept of server at all. You don't have to worry about it. Of course, there is a concept of server. They have to run somewhere, but Amazon will take care of that, and you don't have to worry about how. You pay only for the compute time you consume. That's it. You don't have to worry about managing the resources, and you don't have to pay for the entire 24/7. Okay, if your Lambda gets triggered, a couple of times a day, and each time, let's say it lasts for 10 seconds, then you're only paying for 10 times 2, 20 seconds. That's all. You're not paying for the remaining time. It's as simple as just upload your code, and Lambda takes care of everything required to run and scale your code with high availability. You don't have to worry about the scalability, and you don't have to worry about the availability. It will automatically, deploy it in redundant servers across multiple availability zones. So you will now never go down. You can set up your code to automatically trigger from other AWS services. Yes, you can set up these Lambdas in such a way that call this Lambda function, call this function when an object is uploaded into this particular S3 bucket. Call this Lambda function when somebody makes a HTTP call through something called API gateway. Or call this function when I get a feed. Kinesis, there's a AWS services called Kinesis. So it takes the live feed data stream. So when I receive a stream from these the social media streams, then call this Lambda function. Amazon Alexa is built completely on Lambda. When you ask a question to your Alexa, okay, essentially it's behind the scenes, it's calling Lambda. It's putting a notification out there, and then notification triggers a Lambda. Lambda is what that fetches the answer from wherever it needs to, and then it's echoing back the response. Okay.
So hey Venkat, here you say you pay only for the compute time you consume, right? Mm-hmm. When you say compute time, I mean, just a layman question here. So when you say Lambda, when a Lambda triggers or a Lambda function triggers, does it automatically, for us, yes, it is serverless, but the backend, it is still serverless, or it is just creating an instance at the time, doing your functionality, once it bring back whatever you require, and it's going down. Similar to that.
Right. So what happens is, yes, you kind of nailed it, Ravi. I'll explain, I'll elaborate a little bit more. So what happens is, I'll show you, when we create a Lambda, we'll specify how much memory do we need it. We will not have any control over what the CPU, resources are going to be needed. So just the memory. If you say that I need 512 meg, it will proportionately allocate the CPU cycles to that. And then what it does behind the scenes is that it will create, because there are only so many platforms. You have Java, you have C#, you have Python, you have Node, and a couple of runtime environments. That's all. So you only have 5-6 languages, right? So what they do is they create this lightweight containers behind the scenes. So when a request comes in, that's when it will create a lightweight container, deploy your Java code into it. Okay, it will bootstrap it and then pass your request. So that's why you will see that it's a little slow for the first request, but it will keep the container for so many minutes. It will keep the container for next 5 minutes. Okay. So when a second request comes in within the next 5 minutes, then your container is already ready and your code is already deployed, initialized, everything is ready. It's ready to take the request. It pretty much serves your request. So, but if at all, if you don't get a request until, within that 5 minutes, your container gets destroyed. And then when a fresh new request come in somewhere in the afternoon, then a new container will be created. This is on the fly. It will create a container, deploy your code, initialize your code, and give your, invoke your code. Make sense? That's what happens behind the scenes. Okay, so it comes under function as a service category. There is a separate category called function as a service. So you're creating a function. So I mentioned industry trends since the beginning. You have a physical machine, you have a virtual machines, and you have a containerization, Docker, Kubernetes, etc. And then you have a serverless, Lambdas. What are the benefits? Well, no servers to provision or manage. Just write the code and upload it to Lambda. And don't worry about how it runs or where it runs. You just deploy your code. You don't worry about anything. Continuous scaling. It will automatically be scaled based on your need. Okay. And then automated high availability. It will automatically get copied across multiple availability zones redundantly, so that when one availability zone is down, you will still have your function as available. And you have this sub-second metering. It will calculate based on 100 milliseconds. So if your code runs for 120 milliseconds, I think you'll only pay for 200 milliseconds. Okay, it's a sub-second metering. And you have your consistent performance using, you can optimize your code execution time by choosing the right memory size for your function. So you'll be able to allocate the appropriate memory size for your function. I'm going to show you how in the example. Any questions? There are some downsides. It's not just the benefits. There are some downsides. So let's say you can make this architecture pretty complicated with the Lambdas, because everything is an event driven, right? So when you upload something into S3, your Lambda gets triggered, and Lambda, let's say, take that object, S3 object. Let's say you have a, uploaded a full resolution picture. You take your Lambda actually resized it based on various screen sizes for your iPhone, iPads, and other things, and then put it back somewhere. Upload to another S3 bucket and invokes another Lambda. That Lambda can take them and then put it somewhere, and they move them to one zone IA. So you can make this pretty complicated. Okay, that's why it's very hard to debug. So to solve that problem, Amazon has introduced a service called Amazon X-Ray. X-Ray, using Amazon X-Ray, you'll be able to trace it pretty much what exactly happened, how, who took the, where was the request initiated from, and what are all the services that it went through in a beautiful, pictorial representation it will show you. So, but that's one downside. Okay, how does it work? Just write your code in your popular, in your favorite programming language. You have Node, you have Java, you have Python, you have C#. Maybe you have Ruby. We'll find out. So, and upload it to Lambda. And then set up your code to trigger from other AWS services. So you have your S3. So S3 can be set up as a trigger. DynamoDB, you guys know DynamoDB is Amazon's non-relational database that gives response in single digit milliseconds. If you see anything in the single digit milliseconds and it comes to database, then DynamoDB is the answer for that. Okay, DynamoDB is that powerful. So, and then DynamoDB can act as a trigger for your Lambda, meaning when you insert a new record into your DynamoDB, then it could trigger a Lambda. So you have your CloudWatch logs, your CloudWatch alarms, especially. So when there is a CloudWatch alarm, you can write a Lambda. You can write your Lambda function, and that Lambda function, based on the CloudWatch alarm, it can provision new resources and put them there. You can do that. And you have your simple notification service. You can send your notification through. When a CloudWatch alarm gets triggered, we created a simple notification service, and we associated our email ID to this. So similarly, when there is a new notification on a particular topic, you can have your Lambda get triggered, and then you can do whatever you want to do it. Kinesis stream, social media stream. As soon as I get the stream, you can have Lambda triggered. And your API gateway. So this is what makes serverless possible, serverless web applications possible. So when a request comes in, let's say you are building a RESTful endpoints, RESTful API. So when a request come in on a HTTP request, so it's taken by API gateway. API gateway will act as a front gate for all of your APIs that will take it, and that will apply authentication, authorization, and other cross-cutting concerns there. And then it will forward the request to your Lambda. It can trigger the Lambda, essentially. So yeah, there are a lot of there are a lot more triggering points. So one thing that you must remember in real life and for the exam also is RDS, your relational database service, is not one of the Lambda triggers. Meaning when you insert a row into your weather data, weather table, you cannot have Lambda triggered on that. If you need Lambda triggering for database, then you have to go for the DynamoDB. It's one of the important aspects and very tricky for the exam, and absolutely there will be a question on that. So Lambda runs your code when it gets triggered. So once you set this up, then you upload your object to S3, and then your Lambda gets triggered. Just pay for the compute time you use. It's that simple. Well, let's look at some use cases. I copied directly from AWS itself. So take a look at it. So a photograph is taken, you upload to Amazon S3 into bucket, your Lambda gets triggered. So your Lambda runs your image resizing code. So you wrote and deployed your code. What it does is it will resize the code, and then photo is resized into web, mobile, and tablet sizes. And then probably it will upload those various sizes back into some other bucket in S3. It's possible. Or it can trigger another Lambda that can do it. So this is a web application. So Amazon S3 front-end code for weather app is hosted in S3. Let's say, this is just an example, right? So you have your static website hosted through S3 bucket. Now, let's say there is a link. You click on that link. User clicks a link to get local weather information, and you pass your zip code automatically using geolocation or something. And then it goes to, because you are making an API call, it goes to something called Amazon API Gateway. Amazon API Gateway will act as a gateway, meaning it acts as a front door for all the APIs. And that can trigger a Lambda. And your Lambda runs code to retrieve local weather information from DynamoDB or your relational database service. So we do this one. We do this aspect today. I'll show you an example here. So what we will do in our example is we will upload. Remember I told you guys about this weather information, the CSV file that we created, it has two fields too there. One is zip code, the other one is temperature. So we updated, we used to upload the data into S3, we'll still do that. And then our Java code, we exposed a REST endpoint. That REST endpoint used to pull the data from S3 and insert into a table in RDS in MySQL. What we will do this time is that, let's create a Lambda and we will put Amazon S3 as a trigger point. So as soon as an object is uploaded into that specific bucket, our Lambda gets triggered. Our Lambda will go fetch the data, parse the data, and then connects to RDS and then dump the data into that. Beautiful, right? You know, you can use it for IoT backend. Take a look at this. Tractor sensors send data to Amazon Kinesis. So you have sensors at various levels. You have, you know, engine level sensor, you have a pressure sensor, you have, you know, within the engine, you have 10 other points, temperature sensor, various sensors. So all of this gets sent to Amazon Kinesis as a stream. So Kinesis captures and streams the sensor data for processing by Lambda. It will trigger a Lambda. Lambda will, you know, look at all these data points, and then it will find out that, okay, you know, something is wrong here. So looks like the heat control valve is damaged. Okay, let me go ahead and order a new one. It will place an order for, order is automatically placed for replacement parts. Okay. So this is mobile backend. User posts status update, and your Amazon API gateway. Amazon API gateway is acting as a gateway for all of your APIs. As soon as I change my status, it sends an request to API gateway. API gateway triggers Lambda. Lambda will find out all of his friends. You know, let's say this guy has 100 friends, and then it will send SNS, simple notification service, to all 10 of them saying that, hey, this guy changed his status update. Event. Everything is an event here, right? So you can build serverless backends using AWS Lambda to handle web, mobile, Internet of Things, and third-party API requests. We just saw all those examples there to make that serverless possible. So without delay, let's go ahead and demo it. Let's take a look at simple hello world with Node.js without not much uploading the code. We'll take a look at our Java example as a second demo. But the first one, I wanted to show you how simple it is to do it. Okay. Any questions at this point? Go to services, click on compute and click on Lambda. Okay, I have a couple of Lambda functions here. Let's create a new function here. So when you click on that, this is how it will display. You can author from scratch, and there are some blueprints out there. You can search for your hello world. Let's see if anybody, yeah, a starter AWS Lambda function hello world. This is written in Node.js. Okay, you can use a blueprint and you can author from scratch. I will show you this author from scratch in a minute when we look at it in Java. And then let's go ahead and configure. I'm using a blueprint here. So let's give a name here. Let's say my first function. So I'm creating a simple Lambda function here, execution role. So you guys are familiar with the roles, IAM roles. So there was an IAM role called S3 full access. I believe we created that role, and then we associated that role to an EC2 instance. At that point, EC2 will assume it. will assume that role, so that we don't have to copy the sensitive secret key ID and secret access key, API access key and secret access key. We don't have to copy them. So your EC2 will assume that role automatically. So similarly here, so what do you want your Lambda to do? If your Lambda needs to talk to S3, then it needs to have that S3 role. If your Lambda, all you're doing, this function needs to do is a simple execution. You're doing a simple Lambda execution. That's all I need. I'm not talking to any of these services. Then you use one role. So create a new role with the basic Lambda permissions. This is what I'm selecting, basic Lambda permissions. So all it has is ability to execute your Lambda function. That's all. I will select that. And this is your Lambda function code. You don't need any IDEs. Simple. This is a simple Node.js 12.x console.log loading function. And then exports.handler equal to in an async format. Okay, you got the event and you got the context. So you will get both of them. The appropriate event, what triggered this event, and what's the context around it. So let's say console log value 1, event.key 1, event.key 2, event.key 3, and then you are returning this event.key 1. Okay. So that's all. You can even do, we'll edit that in the next one. So this is the basic function that since we picked up the blueprint, it gave us that. Let's go ahead and create the function. We called it my first function, if I'm not wrong. Yep. So let the function be created, and it's a Node.js function. Okay, this is how it looks in the designer. See here, this is your Lambda function. And then who can trigger this Lambda function after, this is kind of a triggering events. And then after my function is run, can I call any other destination? Meaning, after my function is successfully completed, can I make an additional Lambda call, or can I, can I send my response to another S3 bucket, or can I send it to CloudWatch, or can I trigger an additional Lambda function? So this is in a destination. So this is where it started. This is where my Lambda function is. Do you want to do any post-processing operations? You can call this destination, but let's worry about that later. So this is my function code, console.log loading function. Let's say console.log. Give me the complete event object and then see. Or I'll say my first function has been called. I'm coding here. This is like an IDE. It's a Node.js though. Okay. So code event type edit code inline. Well, I'm doing it, and this is the handler. So index.js, inside that there is a function called handler. That's what gets I'm defining here. So later on, when we look at the Java code here, our handler will be our fully qualified class name and then method name. You have to give a colon method name. Okay, a Java method name. So it's that simple. Any environment variables you want to use, you can use them here. So if you want to decouple your environment variables from your code, then you can provide them here. You can add tags here. I'm not doing any of that. Basic settings, how much memory? Well, I need 128 meg memory, and timeout is 3 seconds. So it has to complete it in 3 seconds. As an timeout, meaning if it don't respond in 3 seconds, it will error out. And this is AWS X-ray. So if I want to look at the active tracing, so then it will tell me precisely who called what. So I'm going to show you this X-ray little later. So you don't have to worry about, you can have this, associate to a specific VPC, or you don't worry about it and let it take care. Concurrency. So unreserved account concurrency is 1,000. So 1,000 concurrent requests can be handled at the account level. So if you want to cap it, if you want to throttle it, let's say my function can be called more, it can be called more than 100 times at the same time. Okay, concurrently, I cannot handle more than 100. I do not want this to be like that. So otherwise, if you want this to be, 10,000, 1 million, you can do that. So it will worry about it. So you don't have to worry about it. So provision concurrency, we'll get back to this a little later. It's a little advanced concept, meaning, yeah, I'll not confuse you guys. So asynchronous invocation, retry attempts, database proxies. I don't have any database proxies. Don't worry about any of that. So let's go ahead and save it. So let's go to functions now. And then my first function should be there. Okay, and what permissions? Well, this is the role. My first function, it created a brand new role with just one policy should be there. Yep, AWS Lambda basic execution role. Very good. Well, now how can I test this one? Well, what I can do is go here, select a test event. I can create a test event, configure test event. So this is what this is a JSON, I'm sending it to my Lambda. Make sense? And event template is hello world, I selected. Or let's say if you want to do S3, so S3, Amazon S3 put, then this whole JSON, this is like your mock object, this whole data will be passed to your function. You can test your function before you associate any triggers. First, make sure your function is coded properly, it's working properly in isolation, like your mock. Okay, make sure it's working fine, and then additional triggers. So let's say hello world. So this is what is sending. Key one is key one value one. Yeah, key one is my key one, whatever value, no, my value one. You can say key two value two, it's anything, right? Event name. So what do you want to call this event? This is a test event, right? So test event one for this guy, and then create it. So what I just created is, I just created a test event, meaning I wrote a simple JUnit like test case with a test JSON data that will be passed to your Lambda. So I'm trying to test my Lambda function in isolation, like how I always do unit tests, if that makes sense. Just click on test. Execution results succeeded, logs. Let's take a look at the details here. The area below shows the results, result written by your function. So what was returned? Your function has returned my value one. Let's take a look at the code. If that's, I'll show you. See this one, you are returning event.key one. So your key one is my value one, event.key one. So this is what we added it. And how much time did it take? 56.92 milliseconds. Resources configured for 128. How much memory used? It's 64 meg. And build duration, 100 milliseconds. Log output. So this is what we printed, right? My first function has been called. This is what we wrote. Value one equal to my value one, value two equal to value two. value 3 equal to value 3. And this first guy is being returned in our event.key1, right? So let's say I can hard code it. I'll just say my first Lambda function return. Okay, so let's save it and then test it. You can look at the log. Hooray, my first Lambda function returns. That's the response, you got it. And then you can take a look at it. My first function has been called, everything, all of your console logs, and then that's it. It's that simple. It's a simple Node.js hello world kind of function. Any questions at this point? This is your code. This is your execution result. Yes.
Can you go over the example once more, please?
Can you what?
Can you go over the example once more?
Absolutely.
Thank you.
I will. So go to services, click on Lambda. Okay. Let's leave this my function. Let's create a brand new function. So there are a couple of ways you can do it here. Author from scratch. If you know what you're doing, I will show you this example in a few minutes using Java. But I want to use a blueprint. It already has some blueprints. So S3 get object, let's say. So this example, there is some code written by AWS guys already in Python 3.7. What this guy does is, if you give an object S3 bucket name and object key, it will go pull the object content and give you that. So when that Lambda gets triggered, that's what it does. So this is a Lambda function written in Python 3.7, and the description is S3 get object Python. So I don't want to worry about anything else here. I just want to search for hello world. There is a hello world, a simple, take a look at this one. There is a simple piece of code written in Node.js. Okay. Just to return some dummy data. Okay. So your function is taking an event and the context. The context essentially, from context, you can get the logs in Java area. I'll show you that in a few minutes. Okay. You can get context around this Lambda function, essentially. So this event will give you about triggering event, who triggered it, and what all they passed it, etc. So, and you can give a name, my second function, or you can call it my hello world function. We're going to create at least few, so I'll guarantee you have you will understand this fully. Don't worry about it. My hello world function, create a new role with the basic Lambda permission, or you can use an existing role. These are all the roles that have already been created. So I can pretty much use this my function role, or understand what that role is, what kind of permissions that it has, policies that it's attached to. Okay. And then essentially what we need is a simple Lambda function, because we are not making any calls. This is where, what do you want to do when this method is called? This method will be called, this whole handler is going to be called when the trigger event happens. I know we did not configure the trigger. We are only creating the function in isolation, and then we will attach to a trigger. So call this trigger, call this handler when I make when I upload a file into a specific bucket. We can do that. Okay. So I can't do it yet. I'll go ahead and create the function. I created the function here. This is my hello world function, and this is my function code. You can do my second function. Okay, you can put anything here, and then you can return. And this is where you can call S3, call S3, get object from S3 bucket. Okay, parses the data. You can do all of that. Parses the data, and then insert into your RDS or DynamoDB. Make sense, guys? You can do all of this, but you need to be familiar with your Node.js. But we will do this example in Java in a few minutes. But it's pretty easy in Node.js, like languages. If you want to provide any environment variables, you can do so. So I'm assuming you guys all know environment variables. So in your Java, if you want to call the system.get property, if you don't want to hard code anything in the code, you can put them as an environment variables. They'll be passed as -d to your JVM. And you can get those using system.get property. And you use tags for your billing purposes. I mean, that's one of the biggest advantage. This is where you can specify that this function is written for finance team. This function is written for HR team. So all the billing that you incur for this function executions will go to finance cost center or HR cost center, like that. AWS X-Ray, I said we will take a look at it. So unreserved account concurrency. So we have 1,000 concurrent for each account, 1,000 concurrent calls, okay, for each account. And out of 1,000, we have allocated 100 to the first function, and we can do it, for another 100. Or we can say unreserved account concurrency. Okay, then it will automatically be taken from this account concurrency. And pretty much that's it. Just go ahead and save it. So you created a function. So at this point, you can do two things. One, when should this function be called? Well, let's go ahead and create a trigger. You can say, see, all of these are triggers, guys. API gateway, IoT, Alexa skills kit, ALB, CloudWatch events, CloudWatch logs, code commit when somebody commits the code, Cognito sync trigger, DynamoDB, Kinesis, S3, SNS, SQS. These are all the triggers. But the only thing that you don't see it here is the RDS, Relational Database Service. When an RDS table, when your database table gets inserted or updated, you cannot set that up as a trigger to kick off a Lambda. If you have a use case like that, then you have to go with the DynamoDB. DynamoDB is Amazon's non-relational database service. Make sense? So let's say S3. I'm triggering S3, meaning what I'm...
Venkat?
Yes.
Quick question. So, I mean, just for information, any reason why RDS is not supported by Lambda?
Why RDS is not supported? It's RDS is all third-party stuff, right? You have your MySQL, you have your Oracle, you have your the relational database is little architected differently. Okay, they cannot raise the events by nature. That's why. But
Okay, and Dynamo, yeah, sorry, good.
The DynamoDB is a non-relational database, and it's all completely, you are not creating a separate database for each user. Raghu is creating and Venkat is creating. Behind the scenes, it does not create two different databases. Rather, it maintains a single database, but everybody gets their own their share. Okay, pretty much. I have my own space. I have my own schema and tables kind of thing. Okay, so that's possible in non-relational database because they created ground up pretty much, right? So it's possible for the non-relational databases, but relational database, no. If you look at it, all of these are AWS, pretty much, these are all AWS products. Okay, and of course you have a partnered solutions also, but the relational database service is traditionally different, and that's why it's good for certain use cases, but it's not a tool for everything. Okay, you have to start thinking about non-relational databases. Yes.
Hey Venkat, I have one quick use case.
Okay.
I mean, just want to go through that thought.
Yep.
So every month we do a table space analysis, growth analysis per se, for our Oracle database. So I mean, we rely on Teams. Sometimes it happens very quickly sometimes. But recently we automated such a way that a Python can log into database, and it will tell us the growth analysis for next 2 months. Okay, how much we need. So for that I have to install a server where the Python runs, logs into SAP, do that analysis for us, bring back a HTML file with all the analysis back. You get my point, like so instead of going through that using that resources and having a separate server to trigger that event, I mean,
who triggers that?
it's a bad. We can schedule it in a task scheduler in the Windows. The task scheduler.
I see.
We can schedule
so
it.
it's not. It's a more of a scheduled event than the true event. Okay. Yeah, you can definitely do that.
So it can log into. It can still do that analysis and bring back. I mean, at the end of the day, code.
Absolutely. In fact, I'm going to show you now. I'm going to show you. Give me another 10 minutes.
Okay.
I'm going to show you the beauty of it. When you upload our weather CSV file, our Lambda gets triggered. Our Lambda will pull the data from S3, parse it, and store it into RDS. So don't get me wrong there. Your Lambda can safely talk to RDS or DynamoDB or any of these services. My point is, RDS cannot be the triggering event. That's all. As soon as I update data in this particular table, I want my Lambda function to be invoked. That is not possible. I hope I made that clear. Understood? So just hang in there. I'm going to show you. So we have this hello world function. Let's go ahead and bucket. I'll call this, okay, let's say javavenkat.com bucket. Okay, in this bucket, event type, HTTP put. What I'm saying here is that, guys, yes, when I do a HTTP put of any object in this particular bucket in S3, go ahead and trigger my Lambda function is what I'm saying. Do you have any prefix and suffix? Meaning not every single object, but objects with this prefix or objects with this suffix only enable the trigger. Now go ahead and enable the trigger. Did you guys understand what I'm trying to do here? I'm attaching a trigger to my Lambda function. It's two things here. You have to create the Lambda function or code it and upload the Lambda function and then attach. First, before attaching, test it in isolation. Make sure your Lambda function works like it should. Once you verify that, attach your triggering event. Here, the event is S3 is a trigger. On this particular bucket, every single HTTP put on this particular bucket in S3 will trigger an event, guys. Will trigger my Lambda. I hope that makes sense. See this one? S3 now triggers this guy. Now, you can go ahead and test it. You can write some unit test. You can test it. Or what you can do now is, let's go ahead and upload a file into S3 bucket. Let's go to S3. javavenkat.com, because this is what we gave, and upload. Add files, download. Do we have index.html? Okay, I'll upload this guy again. There you go. So now let's see if my Lambda got triggered or not. Okay, go to services, go to CloudWatch. Click on log groups. And then my first function, is this what it is? No. Can you give me 1 second, guys? Okay, sorry guys. So the triggered javavenkat.com was successfully added to function, my hello world function. These are the log groups that I have it. So let's go ahead and first delete these log groups. Okay. My first function, delete log group. Okay, I don't have any logs at this point. So now let's go to my hello world function. Let me pause the record.
Yes, Venkat.
Okay, thank you. Okay, so this is what we started, right? My hello world function, and S3 has been, so S3 is the triggering point, a specific S3 bucket and specific object there. Not specific object, actually, it's javavenkat.com and any object created by put. Okay, so this will trigger this Lambda. Okay, so now let's go take a permissions. So, okay, this is the role that that's been given. AWS Lambda basic execution, that should be good. So now let's go. This is a CloudWatch. I don't have anything there. Very good. So where is my S3? Let me open S3 in a separate. javavenkat.com, upload, add file. Okay. Now let's see, where is my logs? What's this one? Okay, policies. Nope, it did not trigger, right? It should have. It's public, yes. And let's take a look at the permissions here. My function role. This guy doesn't have a, let's add S3, Amazon S3 full access to this role. Now that's what my function has. By the way, how do I know resource-based policy? Okay. Lambda obtained this information from the following policy statement. Sure. Okay. My S3 javaanchor.com event time is object created by put notification. Sure. I think this is all good. And what we'll do is let's go to functions configuration. Let's go here, function code. My second function has been, and then I'll call this AWS X-ray. I know your functions execution role doesn't have permission to send trace data to X-ray. So let's go ahead and do it. Yeah, it will do it. It will try to add the appropriate permission to the role. I want to look at the complete trace, AWS X-ray trace. So now S3, let's go ahead and upload. Okay, CloudWatch, anything interesting? X-ray. Click on traces here. Okay, good. My hello world function. Yeah. 320 milliseconds, 25.2 seconds, raw data. My hello world function has been called. Okay. But how long ago was that? Was this my test guy? Last 5 minutes, huh? Last 1 minute. Okay, that's good. Yeah. So my hello world function has been called. Client calls this my hello world function. Okay. What I was hoping to see is the logs. My CloudWatch. Where is this CloudWatch?
Maybe I don't know whether it's relevant. One quick question.
Yep.
So it will work. So for example, you're creating a Lambda within this VPC, right? Whatever VPC we have as, or within. So it will work within this subnets or the servers or applications within this subnet, or I can use this for any other outside subnet too, or outside VPC.
Actually, that doesn't come into picture pretty much because it's, we specify the VPC is none, right? It's it will take care of itself, everything.
No. I mean, for example, whatever target where I want to reach or to get that information from. I mean, maybe.
Let's wait. Let's wait on that. Okay. Okay, this one I created it. Yeah, this is all fine. Let's upload a brand new. Why is that? Oh, is it because it's exact same content? By any chance? Let's okay, let's upload this guy, PNG file. And let's go to CloudWatch log. No. What's the reason? What could be the reason? Okay. How about if you look at X-ray? Anything in X-ray? Last 5 minutes. No. Oh, okay. So X-ray is showing the request. Oh, because I'm doing a console logs. Console logs may not show up there. Okay. So see this X-ray is showing it clearly that you got the request. So this is the most recent one, raw data. Yeah. Actually, it is showing. So the console logs may not show up here in the CloudWatch for Node.js. Okay, it's possible that console may not show in the CloudWatch for for the Node.js, but I'll be shocked though. Okay, so what we'll do is let's go do a first Java function. Since you understand that, right? Now I'm going to show you simple Java code. I'll show you this one here. I have set this up called. I have this Maven-based web app, Maven-based app. So the way you want to create your Java app is that go to File, New, Other, and then select here Maven, and then Maven project. And then you create a simple project, skip arch type selection, and then you select your GAV coordinates, group ID, artifact ID, and version number. Let's say my group is com.nextstep, artifact ID is, let's say, hello world. Okay, my first Lambda one, and then some version number and package as jar file. So this one will show you. This one will show you like this. Now open up your pom.xml and you add your AWS Lambda SDK. So I'll show you where the data setup. So let me close this guy. So open up your pom.xml. So the dependencies that you need are AWS Lambda Java core and then AWS Java SDK. Why do we need AWS Java SDK? S3? Because eventually we want to get the data from S3, okay? And then this Lambda Java core is where, you'll write a class and with a method. So if you want to write a Java Lambda, all you have to do is just write a class, anything, any handler, just name your class name within your package. Your name can be anything, your package can be anything, your method name can be anything, but all you have to do is implement your request handler interface. So there is an interface called request handler. This is from Amazon AWS Lambda. So as long as you implement this interface and you can give what should be the input and what should be the output. So this input will be given to you in your handle request method. It can be handle request or it can be hello, whatever the method name it is. It can be anything, okay? Essentially, this is input and this is output. And now your S3 event notification, this input will be given to you and then along with the context. So this is the same context that we have seen in Node.js. Then all you have to do is just say context.getLogger will give you the log. Whatever log statement that you printed will be shown in your CloudWatch. I'm going to show you that. Okay. And then this is for S3 event notification. So this is for S3 event notification, meaning S3 events will trigger the Lambda. When S3 events trigger the Lambda, it will give you this object called S3 event notification. It will have all the details about, what was that event about. So this event notification dot get records will give you the complete events that happen. In that, take the first one, and then from there you take the S3 object itself, the whole S3 entity. So once you take the S3 entity, you can take the get bucket, and get name will give you the bucket name, and then you can get the object key. So essentially, this S3 event notification object will give you what is the bucket name and what is the object that triggered this this Lambda. Does it make sense? And I'm just returning a 200 OK because I'm returning a simple string here. Does it make sense, everybody? So this is locally I coded it, and now I will build a jar file and then upload it. I'm going to show you how to do that. So what we'll do is, let's do a right click, run as clean package, skip test. And then let's go to this location. Okay, let's get back to your Lambda functions here. Let's create a create a function. Now you show, you select this order from scratch, and now you can say my first Java function. Okay, and then my runtime is, these are the runtimes that are supported. Okay, it's not Java 11, actually mine is Java 8, so I'll select Java 8. So you have .NET, C#, Java, Node.js, Python, and Ruby. That's all. Okay, and of course you have your Node. So my runtime is Java 8. Then it will automatically install JVM and then deploy your jar file there. Okay, so permissions. What permissions do you want it? Create a new role with the basic Lambda permissions. I will create a new role with certain policies. So Lambda, or maybe I have Lambda with S3 full access. Okay, I would like to get Lambda, basic Lambda, no, Lambda. Policy templates, optional. Or I'll do is, let's create the function. We'll go to this role and associate the policies. Let's go ahead and create the function. Lambda with S3 full access is the role that we created and associating to this Lambda function. So we will attach some policies to that. First, let's go to permissions, Lambda with S3 full access. Let's go there and attach policy. It has just Lambda basic execution rule. Let's attach an additional policy called Amazon S3 full access. So my Lambda will have a S3 full access, meaning it will be able to upload objects into S3. It will be able to read it. It will be able to write. It will be able to delete it. It will have everything. My Lambda function can do that. That's what it means. So let's go ahead and close this guy. And this is my first Java function. Go to configuration. And what's the triggering now? Well, first of all, let's upload the code here first. This is Java 8 runtime. And see here, guys, this is what is the handler. First, let's upload the code. Let's upload our jar file. C projects, weather data setup, target, and my jar file. This is my jar file, 6 MB. That's fine, Java 8. And then what is my handler? Your fully qualified class name, : method name. What is my fully qualified class name? This is my class name, : com.nextstep.weather.datasetup.s3 handler is my class name. And then colon, my method name is handle request. I think that's the same. I've used the default method name, but you can use any method name, not a big deal. Okay, so do I need any environment variables? I do not need any tags, basic settings. I need 512 MB, that's enough. And I want active tracing AWS X-ray. VPC, don't worry about it. And yeah, pretty much nothing. Let's go ahead and save it. Let's go ahead and save it. I know we did not attach the triggering point yet. We will attach an S3 here. So let's attach S3 trigger. So my objective is when a file gets uploaded into this, I have a bucket here called next step weather data setup. When a file gets uploaded into this one, I want my I want my Lambda function to get invoked. That's all I'm doing. And then I'll be able to see in these logs in the CloudWatch logs, handle request has been called and my appropriate bucket name and object key. Make sense? This will be my bucket name and this will be my object key. Object key, how do I get it? See this? Key is weather-data.csv file. That's all we are doing at this point. So when I upload a file into the appropriate S3 bucket, my Lambda function will be called. My Lambda function is taking the details from the event notification and putting into the logs. That's all. I'm not complicating the things yet. But I'll complicate the things in the next one, in the next demo. What I will do is, using this bucket name and object key, I will go to S3 and get the content of the data and then connect to the RDS and then parse the data and put it into my RDS. That's fun. Make sense? Okay, so I told you what my objective is. Now let's go to my function. So this is my function. I did not add the trigger yet. My code has been saved. My code has been locally, I got the jar file, I uploaded it. Now let's go to trigger, add trigger, and then S3 is my trigger. And within S3, what bucket is that? Next step, weather data setup is my bucket. And all object create events. All objects are HTTP put. I want to do HTTP put, only HTTP put, meaning when an object get deleted or when an object is retrieved, my Lambda function will not get triggered. Only when I update it or only when I create a file, that's when my Lambda function gets triggered. I don't need any prefix optional, suffix optional. Every single file, irrespective of the prefix and suffix, upload or update should trigger my Lambda function is what I'm saying. And enable the trigger right now. An error occurred. Configuration overlap. Configurations on the same bucket cannot share common event type. Okay. So what it means is I have, let me go ahead and delete this guy. My first Java function is the only one that I wanted to keep it. Let's delete this guy. My hello world function is fine. Yeah. So let's add the trigger. Next step, weather data setup, all object type, HTTP put. That's it. Enable the trigger. Okay. An error occurred when creating the trigger. Configurations overlap. Configurations on the same bucket cannot share a common event type. Configurations on the same bucket cannot share a common event type. Okay. Let's find out. We have nothing at this point, and bucket name is this guy, and enable the trigger. Configurations on the same bucket cannot share common event. Oh. All object create events. Oh, sorry, HTTP put, right? Amazon S3 status code 400 code invalid argument request. Configurations on the same bucket cannot share a common event type. Huh? Interesting. I don't know what it means. Let's find out. Permission, brochures. To verify the setup is to look at the event section of the bucket properties in the S3 console. Do I have some other event? Okay. Don't know what it is. So let's let me take a somewhat cheap route. Let me go ahead and create new bucket and then block all public access. Sure, acknowledge it. Advanced settings, object lock is fine. So I created this new object, new bucket. So let's try this guy. Okay, HTTP put. We'll have to find out what that one is. Okay. So I created an event. I created a trigger event on a different bucket in S3. So when a new file gets uploaded or updated, my first Java function gets invoked. Okay, that's what I did. And I think that's all. Permissions should be good. Monitoring. Do you want to test it? Sure, we can unit test it. Configure it. Let's call it S3. Yes. So S3 put. Let's say this is my test key on this bucket name, example bucket test key. When this is created, my unit test should kick it off. Let's go ahead and kick off. Yes, looking good. So I got 200 okay from our code. See this one? This is what we gave, right? String. And then look at the logs. Handle request has been called. Handle request has been called, this guy. And then bucket name equal to example bucket, whatever the bucket we gave. And the object key is whatever the bucket we gave. Yep. Our Java, our first function should be all up and running. So this is good. Now what we'll do is let's go to IAM. Let's close this guy, CloudWatch. Let's look at all the log groups. Let's go to log groups. My first Java function, I will delete this guy. I want clean slate. I want X-ray. Last 5 minutes, nothing. I'll say last 1 minute. Okay, there is nothing there. Very good. So now I want my S3 management console. Next step is the data setup. Let me go ahead and upload a file. Let me go to data. Let me go to data, where the data.csv file, I'm uploading it. So I uploaded this file in this bucket. Let's go to CloudWatch. Log groups, there you go. My first Java function has been called. Now go take a look at it. Very good. Started request ID, blah, blah, blah. Handle request has been called. This is the same log dot, this is your log statement. Handle request has been called. And bucket name is next step weather data setup 2. Object key is weather data CSV file. Okay, that's it. And you can go to log groups, this guy. Okay, first event, right? Let's go upload one more time. Upload, add files. Let's upload some PNG file. Upload. And then let's go to CloudWatch. Log groups. Or did we specify the object? It doesn't matter what the object, right? Okay, let's wait. Did I upload to the same next step as the data setup? Yep. Let's go to X-ray. Okay, this is the X-ray. My first Java function has been called. Okay, sure. You can look at the raw data. What's been called? Very good. Let's go to CloudWatch. So CloudWatch did not get it. Why? Is it only doing for the CSV file? Let's find out. C projects. Let's go to CloudWatch. Oh, I'm sorry. So all of our requests are going into the same guy. See here, all of our requests have been going into start request ID, handle request has been called, end request ID, start request ID, handle request has been called. I was not looking at properly. So, yep. So weather data.csv file came up, and then in between.
We saw the PNG file as well, right? It's
Yep.
up there.
Lambda.
Yep, it's right there.
PNG.
PNG file too.
I'm sorry, guys. I was not looking at properly. See this one, weather data CSV, Lambda use case IoT PNG, and weather data.csv. Yep. So it's my bad, actually. Yeah, it's a same my function. Yeah, it's a same stream. It's a same stream. Okay. So you can delete log stream, and it will create a brand new stream. Now go upload a new file. You can do this, or you can do completely different Lambda SG. Now go to CloudWatch. So it just takes a couple of seconds. Always your logs, because they happen asynchronously. So handle request has been called, and this is your bucket name, and this is your object key. Beautiful. Make sense? So what did we do so far? Let's go back and take a look at it. What did we do so far is we coded a simple Java function for S3 events. We deployed it. We unit tested with some sample JSON. We looked at the CloudWatch logs. We looked at X-ray for traces. And then we set up Lambda trigger for S3 put events. We uploaded CSV file with weather data. And of course, we did a couple more PNG files, and we looked at the CloudWatch for logs, and we look at the X-ray for traces. Now let's complicate the things. Now what we'll do is, before I look at the demo 3, any questions so far?
Good. So the logs from the first Node.js, did they make it to CloudWatch at all, or?
That one I want to take it, actually. That's bothering me.
Okay.
Also.
Okay. Okay.
So,
no, I just wanted to understand if your logs make it or console log makes it too. That's
I will. I'll find that out and give you the answer to that.
Okay. Thank you.
Okay. Yep. Yeah, that's in my head. And I have 2 kind of action items. One is that, and the other one is the what exactly is this error, right? So I pick up those 2. Where is the error? This is the guy. So let me take both of them.
And maybe you answered this already, like say, S3, if there is no change in the file that I uploaded previously to the current, will it still trigger?
Yep, because it's still a HTTP put.
Okay.
Events did not show up in CloudWatch. What was it? Okay, I got these 2. So anything else? Okay, now what we will do is, now let's complicate the things. Let's finish this this whole project, what we started off with. So I created a separate project for this. One is weather data setup. The other one I called it weather data setup 2. Maybe I'll call it, this one I'll call it simple S3 event handler, and this one is a true weather data setup. So what I did here is that I have a simple S3 handler. Let's take a look at this one. I have a simple S3 handler, same as this event notification. So I took the bucket name and object key that has been uploaded. Make sense? Bucket name and object key that has been uploaded. So in fact, okay, now I'm printing it in the logs. And then what I'm doing is I'm calling this weather data retriever and saying, hey, give me the weather data. I'm passing the bucket name and object key. But there is a bug here in this code. If you look at it, this object key, right? If it's a PNG file, let's say it's an image or, any other CSV other than what I'm looking for, I'm still asking this class to give me the weather data, which is wrong, but that's okay. We'll worry about that. So essentially what this weather data guy, what this guy does is, it will go to use our S3 object. Remember whatever we talked during S3 SDK code? It's the same code. Input stream reader, you convert into CSV records and go through it. You get the zip code and temperature. You know how that CSV file looks like, right? So this is how the CSV file looks like. So this is how it looks like, your zip code and the temperature. Zip code and the temperature. I'll take the zip code and the temperature and I'll put it into this weather object, and I'm creating bunch of weather objects into list of weather objects, and then I'm returning it. Make sense? So once I get it, this is where I am. I get the complete list of weather objects. I'm just putting into the log statement saying these many objects that I got it. And then I'm calling this repository. Essentially, it's a simple DAO class. I put my MySQL details there, and then I'm inserting into it. I'm just using a batch update. I'm inserting into it. That's what I'm doing. Before I insert into it, I'm deleting all the records currently. So for this, the prerequisite for this demo is I have, I've already set up my RDS, okay? And this is how it looks. Okay, let's go take a look at the properties of this guy and let's test. Yep. Okay, connection has been established. So weather.temp lookup, I have a zip code and I have temperature. So there's nothing in this database table. So I have RDS. So I already have RDS set up last night, and I have a database table called, I have a schema called weather. Within that, I have a table called temp lookup. Okay, that's all prerequisite. It's nothing to do with the demo. So essentially what it does is, it's this, once this Lambda gets triggered, this Lambda will go to S3, get the object, the weather data.csv file, parse it, and insert into this one so that my APIs will work. Does it make sense? I told you guys, if you remember this context, when I told you guys about S3 SDK, I told you we will finish this one. We will make it a real event driven when we talk about Lambdas. This is what I mean. When a new data come in, what analyst does is, analyst will upload the new. So let's say we get the weather data every 6 hours from somewhere, from let's say weather channel or government. So we will get it in CSV format, and our analyst does is, she has no idea what's happening. She will just take the CSV file and upload into S3, and then behind the scenes, our Lambda gets triggered, and Lambda will take that data and put it into our RDS so that our APIs will work properly. Make sense? So what I will do is, I will go ahead and run it. I'll put this code in Git. I'll skip it so that it will be quicker. So let's go and create. We don't need a new function. We can create a new function also, but we can actually change this itself. We can change this itself. So my Java 8 and my handler is handler still good. Com next up weather data setup S3 handler. Yep, handle request. Very good. I'll upload my new code. This is my new code though. It's a Java 8 and save. Let's take a look at our S3 event trigger. So what we will do is, today we are testing this Lambda. This Lambda will fetch the CSV file from S3, parse it, and put it into RDS, right? So we will create the APIs using API Gateway tomorrow, and we'll create a Lambda. How API Gateway will call the Lambdas. We'll take a look at that tomorrow. That's final step, and that will be very fun. Okay, so let's take a look at S3 triggers. So next step, weather data setup to object created by put is what will trigger this event. Okay, any questions at this point? You can go pretty much unit test it at this point. before I actually trigger the real event, right? I want to unit test it. I will configure test events and then S3. This is S3. What I will call is, let me give my bucket name properly. This is my bucket name. S3 configure bucket name is this guy. And my object key is this guy. So I'm giving my object, my bucket and object key. So what my code does is it will take the bucket name and it will take the object from whatever I'm giving it. Take a look at the code. See here, get records, the first one. And this is the records here. So within this is a simple JSON. This is exactly what gets given to you in the input here, in the S3 event notification. Okay. So within this, you have a records. So within this, we have a first record. This is the first record, the one I highlighted here. And then dot get S3. Where is S3 guy? S3 is this one, the one I highlighted. So when I get dot S3, this is the object I will get it. So I'll get the schema version, everything, but I don't care about all of that. I'm taking the get bucket. This is my bucket and dot name. So this is my bucket name and S3 dot get object dot get key. This is object, this is key. So I'm taking both of these, and then what my code does is code will will use S3 SDK, go fetch that CSV file, parse it, and then insert into my RDS. Okay, let me go ahead and test it. Click on test. At this point, my S3 trigger is not in the picture. I'm still unit testing my piece of code. I'm still unit testing my Lambda. I want to make sure everything is good. So let's take a look at the details here. I got 200, okay, log output. Okay, weather data list size is 8, okay, in S3 to MySQL Lambda function, okay. Zip code 48083, temperature 23 of, oh, okay, it's printing all of that. And let's see if it really inserted into the database or not. This is my database. Beautiful, beautiful. So what I will do is, any questions so far? I'm still unit testing my Lambda. I still did not trigger an event. What will be the trigger? The real trigger. I'm unit testing it with some simple JSON code.
The real trigger will be when you upload
Exactly.
the CSV file up there.
Exactly, exactly. So let's go to CloudWatch and see now my second stream came in. My second stream came in. This is my second stream, guys. Bucket name, weather, object size, you know, this is all the data, zip code, and finally it's done. So what I will do is I'll go to log group. I'll completely delete the log group. I want this to be empty. You can take a look at X-ray traces. Last 1 minute, okay, nothing. So all good, right? Now I have unit tested my Lambda. Everything is good. Now what I want to do is let me trigger it. Next step, weather data setup 2. I will upload this weather data CSV file, right? So what I will do is I'll give me some more zip codes, guys. 91234, I don't know what. 112 degrees F. 87654, 12 degrees F. Okay, so where did I save this guy? I think upload, add files, weather data setup 2, data, weather data CSV. I'll upload it. Before I upload, I'll do a delete from. I mean, code does anyway, but just for just for testing purpose, right? Just to make sure. Very good. Upload it. Okay, now I can look at my CloudWatch. CloudWatch, the groups. See my refresh. This guy. This is a fake refresh. It's not maybe a defect there. My refresh was not working. So, yep, all of this data. See this 112 degrees and 12 degrees. 91234 and 87654. These two I've brand new added. Let's go database. Very well. 91234, 112 degrees, 87654, and then everything else. That's it. How do you like it? This is beautiful. This is really paving the road for real serverless architecture. Pretty much, you don't have to worry about EC2 instances. You don't have to worry about any of that. It's write your piece of code, upload it, and don't worry about scaling. Don't worry about availability. It will naturally be available even if one availability zone is down, and it can naturally it will naturally grow and shrink automatically because there's no big deal there. So when you write this piece of code and upload this Java jar file, right? What it does is, as I told you, it will create a simple container with JVM as a runtime environment, and it will upload your jar file into that. Okay, and it will register your handler, what your fully qualified class name along with the method name. It will just register. So that is what I need to call it. And then this is your S3 event notification. This is your S3 trigger. So as soon as your file gets uploaded, this is an additional trigger. And this trigger will call Lambda, and it will pass everything about the event, like what S3 object has been changed, what S3 bucket has been changed, all the details. And you pull all the details from your S3 event notification, this input, and then you go get the data, use your S3 SDK, go get the data, parse it, save it into RDS, save it into DynamoDB, whatever you want to do it. It's the sky is the limit for you, or call an additional Lambda trigger. It's that simple.
Venkat, is one of the trigger event like a cron job too? Can it be used as that as well?
Yes. You'll be able to schedule it.
Okay.
I think that's earlier Ravi was asking too. Yes, it's a scheduled job. Yes. So this is how I wanted to end our class with. You have all the data set up here, right? Now, this is a weather data setup. When analyst uploads the new data that we get from government or weather channel every 6 hours, they will upload into S3 bucket, and Lambda gets triggered automatically. They don't know about it, and it refreshes the data. Okay, and then your APIs will work. Now create your weather service. Okay, remember we created another Tomcat-based application, a WAR file that will read from this one. You give me the zip code, I'll give you the temperature. That's your actual application. Now, the beauty is the actual application also, the actual web application also, you don't need an EC2 anymore. You can do it using Lambdas. So you create an additional Lambda. Call it weather service. Okay. Let's say HTTP GET. We'll start with HTTP GET, and then you give me the data. Sorry, you give me the zip code. I will read from RDS and I'll give you the temperature back. But I have the Lambda. Okay, so I got the Lambda, but the Lambda works on the events. So who can trigger this Lambda? Well, the triggering is not going to be S3 or anything at this point, because you want a web request to trigger Lambda. There is a new triggering mechanism, that is API gateway. API gateway will act as your your front door for all of your APIs, that will give you the API, the complete, the URL. There you can define, for your resource, let's say whether you can do HTTP get, HTTP put, HTTP delete, HTTP, options, everything. You can define all of the APIs. Okay. And each one of them can be a different microservice. So, but you will have a unified interface for all the APIs. Okay. So what happens is when somebody makes a request, when somebody makes a HTTP request, it goes to your API gateway, and API gateway will trigger Lambda, and Lambda will process the data or go to RDS, get the response back, and then it will give the response back to API gateway, and API gateway will give it back to the browser. And using API gateway, you can apply some policies like authentication, authorization, anything more. You can put all of them at all the cross-cutting concerns for all of your microservices or all of your APIs at one single place. That's called API gateway. We'll talk about that tomorrow. And how can we finish this one? So we have the data here. How can we create one more Lambda that takes zip code as an input? Actually, that Lambda that can be triggered by API gateway. So when a browser makes a call, how all of this, fit together is the next, the last piece of the puzzle. So that is actually, that is how you can make, you can build web applications also serverless. It's not just for pure event driven. You can build APIs serverless without having any EC2 instances. You can build APIs serverless. How? Because API gateways can act as a triggering point for your Lambdas. That's the beauty. And I want you to really appreciate this concept here, guys. So let's say you have a continuous flow of requests. I mean, your EC2 makes sense, no doubt about it. But if you get so many requests, if you get so many, very less requests, or your requests are distributed across the different time zone. So morning time, couple of requests, afternoon, couple of requests and all. So you don't need to have your EC2 instance up and running all the time, 24/7. When a request comes, your Lambda will get invoked. It will take your request, give you the response back. Okay, and you'll only get billed for those many milliseconds. As we said, the sub-second metering, right? It's 100 milliseconds each time. So let's say your Lambda got invoked 100 times, and each time it was able to do it in 100 milliseconds. Okay, and then you'll be charged for 10 seconds of compute. That's all. You're not charged for the whole day. So that's the beauty of it. And it will scale infinitely. Scalability, availability, you don't have to worry about it. So, yep, no worries, take care of it.
Venkat.
Yes.
The way we have some criteria for add trigger, do we have any criteria for destination as well, or we can send it out to anything?
I did not follow it completely, Ketan.
Okay, so if you open up the Lambda page, and when we do the added trigger, right, we have some criteria, like we can trigger either from the DynamoDB or S3 or, yep. Right? Same way we have other end, like is like a post processing add destination, right?
Yep.
In that, do we have any basic criteria that we need to follow, or we can send it out to anywhere?
It's up to our use case.
Okay.
After this function is completely, see this one here, on failure, this function failed for some reason, send an SNS notification to an SNS topic. Okay, or you trigger an additional Lambda function. Okay, but you don't need to do anything too.
Okay.
if that's what you're asking.
Yes, yes.
This is what do you want? Do you want any post processing to be done after Lambda is invoked or after Lambda is executed? Do you want any post processing to be done? Is essentially this add destination. Fair guys?
Yep. So probably like, and we need to create, and let's say we have something updated, and then we need a kind of a send out an error email stating that,
Yeah.
oh, this has been completed. This kind of those things.
Sending event notification
I got it.
is one of the best SNS, right? Simple
Yep.
notification service.
Yep. I got it.
Sending a notification to somebody, sending an email saying that, yep, your batch job has been complete. It's very fair.
Yep. I got it.
Okay.
Hey, Venkat, quick question.
Yes, go ahead.
So when you're uploading this code to the Java file to GitHub, can you also add instructions as to where we need to customize it so that it connects with our instance in a bucket?
Definitely. I like that idea. Okay. So essentially, all you need to do is, if you follow weather data setup repository here, these 4 ones, these 4 pieces. Okay. In fact, since you asked, in general also, the driver class and the URL, username, and password. Can anyone tell me what's the better way to do that? Is this a good way? In fact, this is not. This is a lousy way.
You have to externalize it. Yeah.
Exactly. We just looked at something called environment variables here, right? We looked at the function. We looked at the something called environment variable here, right? See here. Create 4 environment variables. 4 environment variables: driver class, JDBC URL, username, and password. And here, instead of hard coding system.getProperty, if I had done this one, then pretty much you don't have to do anything. System.getProperty, and then you say driver class name. Okay. So what you have to do it here is that just create an environment variable, manage environment variables, add an environment variable, driver class name equal to this guy. Then I'm moving from code to this one. Make sense? So just JDBC URL. And all you have to do is find out what your server name is, your port number is, and your schema is. Just provide it. This is create your JDBC URL. Pretty much. Makes sense? Regu, did I answer your question? I mean, I'll put it in your README though. I'll put it. Add instructions to changes that need to be done. Okay. We'll do that. And I'll add, same exercise as a homework, guys. Same exercise as homework. And please, I want you to finish this exercise today. Then you'll be able to appreciate tomorrow's class even better. API gateway, because we have the data. Analyst has loaded the data here. We appreciated the lambdas and how the function as a service works, right? When an S3 event triggers, then how magically our lambda function gets called and all. Okay. Now tomorrow, how can we use this for your REST API also? That's where you'll be able to appreciate the real serverless web apps. That's a new concept, right? New meaning last couple of years. Okay. Anything else? Were you excited? I mean, I was very excited. This topic is one of my favorites, along with API gateway. So,
Venkat?
yes.
There's also some place wherein you have to give the AWS access key and the secret access key, or is it not?
Good point. Very, very good point. Anyone wants to take the question? So let me rephrase Raghu's question here. Your Lambda from your local machine, when you talked about S3 SDK, you had to give your secret access key and API access key, right? So you had to put them as a system.set environment. Sorry, what is that? System data set environment variable or something, right? So you have to create those environment variables. So how come you don't have to do this one? I did not put any of that here. How come?
Because of the role, right? We are assigning the role to it now. So it is pulling from the role, not from the...
That's a correct answer. Because Lambda has assumed that role. We gave this Lambda function, when we created this go-to permissions here, this Lambda assumes this particular role, Raghu.
Okay.
Whatever this role name is. This role name can be Raghu role, not a big deal. Okay. This Lambda assumes this role, and this role happens to have two policies attached to it. One is Amazon S3 full access, meaning it will be able to do everything in Amazon S3 on your behalf. You don't need to provide your API access key and secret access code. And that's not a good way to do it, actually. This is the right way. The role is the way to go. Remember, even when you did that S3 CLI, to start with, we put both of them, and then we assign the role to EC2. After we assign role to EC2, pretty much we don't have to give it. You remember that? So because of this role, you're able to do it. Good stuff, guys. So anything? And I will try to share the PowerPoint also. Okay, let's take a look at the final demo and then see demo 3, right? I think we finished it, but let's take a look at it. So let's change the code to read the S3 object data, parse it, save it into RDS weather table, verify that the Lambda is called with CloudWatch and X-ray. We verified that, and verify that the data is written into database table. Prerequisites for this one is you have to have a S3 bucket, because you have to add that as a trigger to your Lambda. And then you have to have RDS with MySQL database or any other database, as a matter of fact, as long as you provide your JDBC URL. Weather table to hold the data. You need to have this database table. Okay, we'll conclude with this Lambda triggers. Who can trigger Lambda? API gateway can trigger, IoT can trigger, skill set. This Alexa skills kit is nothing but you are calling Alexa, what's the temperature outside? That actually triggers Lambda behind the scenes. Application load balancer, CloudWatch logs, DynamoDB. DynamoDB, understand it, in the databases, there is only one that can trigger, that's DynamoDB. It's Amazon's NoSQL database. And your S3, of course, simple notification service and simple queue service, both of them can trigger Lambdas. And Kinesis stream coming from this social media stream. And I believe that's it. I know I put more, but these are the main Lambda triggers. But the most important piece is RDS is not one of them. This, I want to emphasize it. He will trick you in a couple of ways in the exam. He'll put RDS as one of them, including Aurora. Aurora is Amazon's own, database, but it has some of the great features on the other side, but it cannot be a triggered. It cannot be a trigger for your Lambda, any RDS. Okay. So can you finish the homework by tomorrow?
Okay. Hey, Venkat.
Appreciate it.
Venkat?
Yes. Mm-hmm.
Oh, this is Srinivas, Venkat. Can you just take a minute and show me that the GitHub thing? Last time you put it, just like how to take that.
Yes. We'll do that. So let me change to your okay. So GitHub. So let's add both of them, right? Weather data setup and weather data setup 2. So let me. So I have one repository called weather. Okay. So here, click on weather. I mean, I did it. So go to clone or download. Click on clone with HTTPS. You can do that. And then save this URL. And then go to your Eclipse. And then go to, I know I have your Git repositories here, but if you don't have it, window, perspective, open perspective, and Git, Git perspective, and then click on clone, and then select it. It will automatically select, and you can enter your user ID and password pretty much. This is public, right? You don't need, I mean, I will use it for my stuff, but you don't need any user ID because it's public. Click on next. And then I'll call this weather 2 and then save wherever you want to save it and then show origin. It will automatically pull you into this one. See, it is showing you here. So you just pulled from GitHub into your local machine. Now click on working tree. And here you have your weather app, right click on it and then just say import projects. And that's it. Because weather app already exists. So change your name and invalid directory folder. Okay, let me see. Select at least one. Okay, click on this guy because it already exists. So what I will do is weather app, right? Okay, let's go to our Git repository. Okay, so select this weather app now and then finish. It's that straightforward. Yep, your weather app is now exists here. Does it make sense?
Yes, thank you.
Project.
So
You need
you
help.
still did not put, yeah.
Java may not your day-to-day job. That's not your primary programming language, so I can help you. So no worries. Right after this,
Yeah, thank you.
if you want to show me. So let's make sure you are able to pull it also. Okay. So what I will do is I will go ahead and commit this guy. I'll do shared project. Side weather. Sure, what email ID I've used here. I think I've used a different one. So. Yep, it's wrong. So okay. Just don't need to wait, but I'll, if you want, if anyone needs help with this one, I'll do it right now. Okay, that's, okay, it's already pushed. So okay. Okay, so within weather, you have weather data setup. Oops, actually I wrote. Yeah, that's fine. So you got weather data setup now. So I'll make sure, you know, all the previous ones also exist there. So do you guys need any help? Srinivas? Let me stop recording. I think at this point we can safely stop.